Welcome. In this video, I'm going to go over how to compute probabilities that result when drawing cards from a standard 52 card deck. Here is a diagram in case you are not familiar with the cards in a standard deck. Part A. What is the probability of drawing a card whose value is smaller than 5? And for the purposes of this problem, we are going to count the ace as a 1. So quickly, let's notice there are 4 different suits, and each of them have identical card labels. The only difference is the symbol spade, club, heart, or diamond. So we really just need to count up all the values smaller than 5 from one suit. And those are these values, 4, 3, 2, and the ace. And there are 4 of them. That tells me that there are 16 total cards that are less than 5. And I went ahead and highlighted them here. Now, before we continue, let's go ahead and name this probability. Let's go ahead and name the event, So the event of drawing a card whose value is smaller than 5, let's call that A. We want the probability of A. And as I said, there's 16 total cards smaller than 5 and 52 cards total. This yields 4 over 13. And as a decimal, we get 0.3077. Part B. What is the probability of drawing a card that is not a jack? So let's label this event, drawing a card that is not a jack. Let's label that event B. Now the probability of B is what we're going to work out. Let's start by counting the number of jacks in this deck. There's 1, 2, 3, 4, and there are 4 jacks in every standard 52 card deck. But we want the probability of not drawing a jack. So let's actually use the fact that the probability of an event plus the probability of the complement of this event equals 1. That tells me that the probability that I seek of this event is just 1 minus the probability of the complement of this event. As a reminder, we can also refer to the complement B prime as B with a bar over it. So I know how to compute the probability of a jack coming out on our next draw. That's going to be 1, 2, 3, 4 out of 52. So this is 1 minus 4 over 52, which is 52 over 52 minus 4 over 52. This gives us 52 minus 4 over 52. And that's just 48 over 52. And let's just fill in the left side of this equation all the way down. So this tells me that the probability of not selecting a jack is 12 out of 13, and all I did was reduce this fraction. As a decimal, this becomes 0.9231. Part C. What is the probability of drawing a face card? And as a note here, the ace is not a face card. The face cards are the king, queen, and jack, and they're called face cards because they have faces on them. Well, really quickly, we have 3 face cards per suit. So that's 12 total face cards. Next, the probability of drawing a face card, drawing a face card, let's call that event C. I want the probability of C. So the probability of drawing a face card is 12. That's 12 total face cards possible out of 52. That's 3 out of 13. And this is 0.2308. Part D. What is the probability of drawing an ace? Well, there are 1, 2, 3, 4 total aces. That's 1 ace per suit. And we need to name our event, so that's drawing an ace. We're going to call that event D. So the probability of D is equal to 4 out of 52, which is just 1 out of 13. And that works out to be 0. Oh, excuse me, I forgot my equal sign. 0.0769. Part E. What is the probability of first drawing an ace, then a king? So this assumes 2 draws, and I'm going to name my events. A is draw an ace, and K is draw a king. What we're looking for is the probability of drawing first an ace, then a king, which we can write as the probability of drawing a king, given that we've already drawn an ace. Now, there's a little bit of information we want here. We're assuming that we're not putting this card back, so we're sampling without replacement. And for now, since we haven't discussed independent and dependent events yet and how they relate to with and without replacement, I'm just going to write without putting the card back. We'll get more into independent and dependent events in the next module. So in this case, we want first the probability of drawing an ace. So that's 4 out of 52. And as a reminder, this is the probability of drawing an ace. Now to that, we're going to multiply the probability of drawing a king. Now, of course, we already have drawn one of these aces and we're hanging on to it. So instead of having 52 cards left total, we only have 51. And if you can't see that, cross one of these out. Say you drew the ace of hearts. There are no longer 52 cards in the deck. There's just 51. And out of those, there are still 4 kings, however. All right, so let's go ahead and work that out. This becomes 16 divided by 2,652. And I'm out of space here. So let's move on to the bottom here. Again, this is the probability of drawing a king given we've already drawn an ace. And we have that it's 16 over 2,652. As a decimal, that's going to work out to be, actually, we can still reduce this. This is 4 over 663, and as a decimal, it's 0.006. Next, part F, what is the probability of drawing an ace and a king with 1 draw? Well, this is this is a trick question. If you're drawing 1 card, you cannot possibly draw both an ace and a king. So in probability notation, we can write this as probability of draw ace and king with 1 draw, and that's 0. Part G, what is the probability of drawing an ace or a king with 1 draw? And again, drawing an ace is event A, drawing a king is event K. And let's go ahead and write this as the probability of A or K. Well, this is the probability of A plus the probability of K. And I'm running out of space, so bear with me. There we are. That's more space now. And from that, we subtract the probability of A and K. And remember, in the last example, we noticed that this is 0. So really, all we end up with is the probability of A, or K is equal to the probability of A plus the probability of K. Well, there are 4 aces out of 52 cards, plus 4 kings out of 52 cards. And to make sure it's clear where I'm getting these values from, I'll go ahead and highlight the corresponding values, or the corresponding cards here. So this becomes 8 over 52, and this will reduce to 2 over 13. So this is the probability of A or K, probability of A or K, and as a decimal, we'd write 0.1539. 8. Finally, what is the probability of drawing 2 aces in a row? And I'm going to add here without putting the card back. So we want the probability of 2 aces in a row. So that's the probability of drawing an ace, given we've already drawn an ace. Well, let's begin by first finding the probability of drawing an ace out of this deck is going to be 4 out of 52. So this is because there are 4 aces in this deck, and those are here. And then we're going to draw a card, and let's say that you drew this time the ace of diamonds, so that's gone. Now there's only 51 cards total, and out of those only 3 are aces. All right, so the probability of A given A is equal to 4 over 52 times 3 over 51. And this is 12 over 2,652. That is 1 divided by 221 is a reduced fraction. And as a decimal, we end up with 0.0045. I hope you found my video helpful.